This question is frustrating because it doesn't have a line reference. But remember, if there's a question with no line reference in the midst of a bunch of other questions, it's not going to be like a main idea question. Those are pretty much always at the beginning, the first one or two questions of a passage. So this means that this is asking about specific lines, but they just haven't told us those lines. So the first thing that I would do is try to narrow my focus to the lines that are going to matter the most. So I would look at questions 26 and 28. What are they asking about? Hopefully they have line references. If not, I can go even further afield. But generally speaking, the chronology rule tells us that the questions are generally in the order in which the lines or the answers appear in the passage. So we can use surrounding questions to estimate where to look. For 26, we get a very traditional question about the vocab, so that's line 17, and then 28 is line 45. So that means that the answer to 27 is probably between 17 and 45. Now, if I'm wrong, if the chronology rule fails here, then I can always read more. I don't, need to kind of like restrict myself to this. But the good thing about the no reading strategy is it lets us start with less and then use things like the chronology rule to read more if we need to. And if we still can't find the answer where we would expect, the whole passage is there. You can always read more. Nothing is preventing you from doing that. So let's start with that, 17 to 45, and let's make sure we understand what we're looking for. We don't want to just read lines in a vacuum. We want to make sure we have a plan. We are hunting for an idea. We are not just reading to understand everything. We want to understand this one thing. So according to the passage, why was the TTV technique difficult to implement before the data from the Kepler spacecraft became available? So that's a very specific claim. That's another reason I don't think this is a main idea question. It's about some very specific idea. So let's take a look at the 17 to 45. So it's basically here. So why was it difficult? Okay, traditionally they have resorted to ground-based telescopes to determine it, so maybe we should go back a little bit here. To know whether it is rocky, gaseous, or some mixture of the two, astronomers also need its mass. Traditionally, they have resorted to ground-based telescopes to determine it by measuring the wobble of the star as the planet tugs on it, but TTV can determine masses from transit data alone. Okay, well that's saying something is maybe difficult or different, but it's not TTV like before and after something in the TTV with the Kepler spacecraft. It's about before TTV existed and then after TTV existed. So the time is not the same as the time difference that they make in the question. So let's keep reading. The technique was the brainchild of Matthew Holman, an astrophysicist at Harvard University, and others. If two or more planets happen to be orbiting a star in close proximity, they reasoned, their gravitational tugs on each other would alter their orbital periods. If one of them was a transiting planet, dimming the light of its planet stars that passed through the star on the Earth, astronomers would see its transiting time vary over multiple orbits, betraying the presence of a companion planet. If both planets were transiting, astronomers could measure the perturbations in both their orbits and work out the planet's masses. I'm reading so fast because I know this is not telling me something difficult about the process. It's telling me just that this is the process. So let's keep going. Holman and a colleague published the idea in 2005, and Eric Eagle of the University of Washington, Seattle, and colleagues put forward a similar scheme almost simultaneously. For years afterwards, however, astronomers failed to detect transit timing variations because almost all known exoplanets were gas giants spinning around their stars in tight orbits. Theorists think such planets formed farther from the star and later barreled inward, clearing away any potential wobble-inducing companion. So I barely understand what I'm reading here, but I do understand this is a problem with TTV, and hopefully it's a problem that's going to get resolved. Let's keep reading. The technique became practical thanks to the Kepler spacecraft, see another idea from the question, which until 2013 was monitoring the brightness of 160,000 nearby stars for the telltale dimming due to transiting planets. Kepler began delivering data on dozens of planetary systems, many of them consisting of multiple planets. In 2010, astronomers began making TTV detections. Their expertise has been growing ever since. So here we go. I guess it has something to do with this. Kepler was monitoring the brightness. So they were able to use the brightness of the planets. I don't really get it, but let's see what the choices tell us. Maybe that'll help. So what was the problem? Why was it difficult to implement before Kepler? TTV requires the existence of companion planets, and most known exoplanets prior to Kepler did not show evidence of companions. Well, the companions thing I definitely read. It's right here. So theorists think such planets formed farther from the star and later barreled inward, clearing away any companions. So there were no companions for the stars that they were looking at. It's kind of what this says. Most known exoplanets did not show evidence of companions. Now, I don't know if that's right. I don't understand the science enough to be certain here, but I don't know. They're talking about companions and the lack of companions, and then, so is this choice? I don't know. Let's look at the others. B. TTV requires several different sets of data for confirmation, and prior to Kepler, only a single set of data was available. No, it's not about how much data. It says the data is a problem, not that they didn't have enough data, or at least that's not what I understood here. So this is about number, quantity, and quantity is one of those things that I'm always on the alert for. It's a potential trap here. Yeah, several different sets, a single set. That was just not talked about. TTV requires that a planet orbit a parent star, and prior to Kepler, the location of the parent stars of exoplanets was difficult to determine. They didn't know where the stars were? Is that what they said? For years afterward, however, astronomers failed to detect transit-timing variations were gas giants spinning around their stars in tight orbits. It sounds like they know where the stars are. They're around that star in tight orbits. It formed farther from the star. So they talk about the star, but not like we don't know where it is. We seem to understand where the star is. So the location of the parent stars is difficult to determine? No. D. TTV requires that the mass of a planet be known, and prior to Kepler, the masses of exoplanets were impossible, oof, so strong, to ascertain. Well, I know why some people pick that. We did read that up here. This is a little bit of a trap, right? They're talking about the stars and using ground-based telescopes. But notice what the choice is saying, that it was impossible to ascertain the mass. But this is saying they resorted to ground-based telescopes to determine the mass by measuring the wobble. So that doesn't sound like an impossibility. It sounds like they did it. They just used a different telescope. I don't know. So plus, when we actually get to this part here, where we see the answer, the difficulty is, they're not talking about mass at all here, right? They're talking about gas giants, I guess, but then it's not about whether or not they knew the mass. So this is just wrong too. So A is right. It had this simple idea about the companion, planets. And then it says here that there were no planets, or there were no companions, because the gas giants are so big, they just like knocked them out. I don't know how planets work, but I don't care, because I'm just trying to understand what they're saying about the planets and this thing. They're giving me the information. And this is a benefit of the questions that don't have line references, is they can be annoying at first because we don't have a line to specifically go to. But if we can use things like the chronology rule, then most of the time, the answer is kind of just said in the lines. I get that this one is a little bit interpretive, but it's still really just saying there, if you think about it, there were no companions. And that's what choice A says. So the difficulty in a no line reference question is finding the lines. But usually once you find the line, it kind of just says the answer. Whereas for the questions that do have lines, most people get those wrong because they know exactly where to look, but they don't know how to interpret what they're reading, or the choices have such good trap answers that they don't know how to sort through them correctly. So everything's, there's difficulty in both directions, right? It's not like these are necessarily harder than questions that give us lines. It's just they have a slightly different approach. So make sure that you're using that chronology rule. The way I think of it is anytime I'm doing a reading passage, it's like checking my mirrors when I drive, right? You're always looking around at everything else around you just to make sure that you're safe where you are. So you got to check over the surrounding questions. What's coming up? What are the other lines? Is it an evidence pair, right? You got to think about what else is going on so that you can use the other questions to kind of narrow your focus and steer you towards where the answer might be. And sure enough, the answer was within the lines we would expect, right? It was in this paragraph here. I did go a little beyond that to get some more context, but actually I didn't need that because the question wasn't asking about the solution to the difficulty. It was asking about the difficulty itself. And this paragraph was just that solution, and the difficulty or the problem was right here, exactly where we'd expect. So use the chronology rule. It really does work.